In the rush of our daily lives, it's easy to forget how insignificant we are in the grand expanse of the cosmos. The honking horns, the ringing phones, the chaotic hum of city streets, they're nothing more than fleeting moments in time. But when you look up at the night sky, you're not just seeing stars. You're looking back in time, into the distant past, to a moment when the universe was born in an explosion of fire and chaos. Before those stars existed, the cosmos was dark and empty. So, what happened before that? What was the universe like before the first stars appeared? Let's journey back. The story of the stars begins 13.8 billion years ago, at the very moment the Big Bang occurred. This was no ordinary explosion. It wasn't an explosion in space. It was an explosion of space itself. Imagine a singularity, a point smaller than an atom, containing all the matter and energy of the universe. In an instant, it expanded. For the first few minutes, the universe was a boiling, dense soup of particles, quarks, gluons, and photons, too energetic for atoms to form. But as the universe expanded and cooled, protons and neutrons began to form, setting the stage for everything else. For nearly 380,000 years after the Big Bang, the universe was nothing but darkness. This time, known as the Cosmic Dark Ages, was a period of isolation and silence. There were no stars to break the cold emptiness, no galaxies to light up the sky, just the quiet drift of hydrogen and helium gas, spreading out across the vast expanse of the universe. It was a time when the universe itself was still finding its shape. As the universe began to expand and cool, hydrogen and helium atoms started to come together, but they were too far apart to interact meaningfully. There was no light, no energy coming from these atoms, only darkness. With no stars to shine, the universe during the Dark Ages was cold and void. The particles of gas were scattered across space in such a thin density that they couldn't form into anything solid. Gravity, though, was already at work. It began pulling these particles together. While the universe was dark, gravity was shaping it. Slowly, over millions of years, gravity began to pull the hydrogen and helium gas into ever larger clouds. These clouds would eventually collapse in on themselves under their own weight, but not yet. This would take time, hundreds of millions of years before the first stars would light up the cosmos. The Dark Ages weren't completely empty. Within these clouds, something incredible was happening, though it wasn't visible yet. Deep inside, the gas began to condense, heat up, and gather energy. As time passed, these gas clouds continued to grow in mass, and the process of gravitational collapse continued. Slowly but surely, regions of space began to condense. But there was one more crucial element needed: density. Once these clouds reached the critical density, the temperature inside would rise to the point where nuclear fusion could begin. That's when the first stars would ignite, ending the cosmic dark ages and starting the era of light in the universe. About 200 million years after the Big Bang, the universe began to change in an extraordinary way. Gravity started pulling together vast clouds of hydrogen gas, causing them to collapse and heat up. In the heart of these clouds, the first stars were born. For the first time in the universe's history, there was light, shining through the darkness after nearly 200 million years of cosmic darkness. These first stars were colossal, much larger than our sun. They burned far hotter and brighter, casting light and energy across the universe. These stars are known as Population 3 stars. Their light marked the end of the long cosmic dark ages and sparked the birth of starlight in the universe. These stars didn't just light up the universe. They also started to change everything around them. The energy from their immense heat caused the surrounding gas to ionize, This process, called reionization, made the universe clear and allowed light to travel freely for the first time. Imagine it's 400 to 500 million years after the Big Bang. The first stars have lived and aged, and now they face their inevitable end. These massive stars, having burned through their fuel, collapse under their own gravity and explode in a cataclysmic supernova. The shock waves from these explosions spread out across space, creating ripples that carry away the heavy elements they forged. This event marks a turning point. These elements, like carbon, oxygen, and iron, are not just scattered into space, they become the very building blocks of future stars, planets, and life. Without these supernovae, the universe would have remained a cold, barren place. Through the death of these first stars, the universe gained its first essential elements. In the aftermath of the Big Bang, the universe was in a state of near-perfect chaos. Scattered across vast distances, clouds of gas and dust, primarily hydrogen and helium, wandered in the empty void. These were the building blocks of everything that would come: stars, planets, and galaxies. But they were not yet bound together. There was only the quiet, waiting potential for something much larger. Somewhere in this void, a subtle, yet powerful force began to stir: gravity. The gas clouds, once diffuse and scattered, began to pull themselves together. It was a slow process, taking millions of years, but this gravitational force began the first step of what would become the creation of something vast: a galaxy. But there was more at work than just the visible matter. Around the newly formed stars and gas, there was something invisible, something that could not be seen with the naked eye, yet shaped the galaxy in profound ways. This was dark matter. Dark matter, though invisible, exerts a gravitational influence. It serves as the scaffolding upon which galaxies are built. Without dark matter, the galaxies would have torn themselves apart long ago. It was the unseen architect of the universe, shaping galaxies from the very beginning. As the galaxy continued to grow, stars continued to form, while others died in supernova explosions, seeding the surrounding space with elements. The remaining gas cooled, and regions of the galaxy began to form spiral arms, stellar nurseries where new stars were born. The shape of the galaxy was becoming clearer: a spiral, an elliptical, or perhaps even a barred structure. From the ashes of the first stars came new stars. The galaxy was no longer just a collection of random lights in the sky. It was a living, breathing entity. Each star, each planet, each element was part of a larger cosmic cycle of life and death. Around 1 to 3 billion years after the Big Bang, the universe has begun to take on a familiar shape. Galaxies no longer float aimlessly in space. They've begun to cluster together, pulled by gravity into massive superclusters. Meanwhile, new stars, fueled by the elements from supernova, continue to shine brightly. Around these stars, planets begin to form, and some of them, like Earth. The universe has started to grow into a vast network, a cosmic web where galaxies are connected by huge threads of dark matter, and the vast emptiness between them is known as cosmic voids. These developments set the stage for a more structured, interconnected universe. As stars, planets, and galaxies continued to form, the building blocks of life began to settle into place. Fast forward to today. We are standing on a small planet, in a small solar system, within a small galaxy. And yet, we are a part of something far larger than we can comprehend. Every atom in our bodies, the carbon, the oxygen, the nitrogen, was forged in the heart of a star billions of years ago. Over the course of billions of years, from the first flashes of light to the complexity of life itself, we have evolved. Our minds have the ability to reflect on the very origins of the cosmos, the journey of the universe from the Big Bang to the present day, is also the story of us. We are, in every sense, the universe becoming aware of itself. While our place in the vastness of the cosmos may feel small, our existence is the culmination of billions of years of cosmic evolution. We are not only a product of the stars, we are their legacy, and we have the power to explore beyond the stars. Who knows what the next chapter in this cosmic journey will hold?